All right. So welcome team for recording to session 5 of our GenAI Agentic AI training program. Just to give a recap, last 4 weeks, 4 sessions, we have talked about the GenAI architecture landscape. Then we talked about the LLM models, different types of LLM models. Then we talked about prompt engineering. We talked about um, embedding models. We talked about vector databases. Then we looked at how we build a similarity search application last week, right? So that's where we stopped last week. Okay. So anybody who wants to take a shot at what is involved in building a semantic search application, where is semantic search application used? What do you mean by semantic search?
So semantic search is mainly for relevant to the meaning and instead of exact to SQL comparison.
It's a similar search.
Similar search.
Okay. Yeah. Okay. Yeah. Similar search. How does what are the components involved in the semantic search? What do you need to build a semantic search application?
So we need embedding, respect to model,
Embeddings, yes, and vector database. Okay, nice.
And after that, if you use this vector data map to any LLM, then you can find through user queries. It is going to find that queries based on instruction and context. Then it is going to extract the relevant information.
Awesome, nice.
Let's suppose, as you told, right, Hawaii is the weather is cold. So we can find if a user given the query like it is to freeze. So cold is almost similar to freeze, right? Little bit the distance is different. So whatever the meanings, it is going to extract the data, and then it is going to push to the user.
Right. Awesome. Yes. So it is based on similarity search. Whatever query you give, we convert to embeddings. You go to vector database, bring out the relevant results. That's where we stopped at with its semantic search application. Now, when we want to extend it to make a chatbot, all we need to do is get added this one, right? So here we did all this part and we did this part up to here. So we just need to add a LLM model to this, which can take all of this relevant data that you get to search results and the user query, use these two to come out with a response. So that will complete your RAG architecture. And
Arun, your screen is not shared. Sorry.
Sorry?
Your screen is not shared.
Oh, not shared. Oh, I thought I was sharing. One second. One second. Hey, Girish. Good morning. Okay. So I was talking about this picture. So we built all of this left part, embedding user query relevant data. Up to this is your semantic search. And you need to add this model, which will take this relevant data from here and user query from here. Go use these two to come up with a user response in a user readable format. That's all your RAG architecture does. And that's building your chatbot to answer your questions, right? Now, what are the use for a chatbot, right? Chatbot can be your internal. Can we put Satya? Can you go on mute, please? So internal. So internal applications for employees. Just say you want to search for any HR policies. So that kind of internal chatbot where normally what you would do, you log into intranet application, you go to Confluence pages or you go to your HR and then click on policies. There will be a bunch of documents. You open the relevant one and go through it and find your answer. Instead, you can just open internal chatbot and then type your question just like you ask in a human language. What is the dress code for the office? Is it business casuals? Can I wear jeans to the office? Or what is the maternity leave policy? Or what is the paternity leave policy? Or what is the block period? So all of these questions you can directly ask, and your RAG architecture can go through all of the documents which already has its knowledge, search for the results, and then it give you the exact answer to your um, user query. Okay, so that's one example. External applications like support, customer support application, for example, is something that you would build to kind of so let's say you have a electronic gadgets. So, you sell something like washing machine, and then you have user manual, you have troubleshooting guide, you have FAQs and all of that. And customer asks a question about the issue he's having. You can build a RAG to and feed all of those documents you have to it, and then it can read and answer the question from the information that you have provided to it. So out of the two problems, limitations that we had for RAG, the first one, that it does not have knowledge about internal information, confidential information of the company. And the other one is its cutoff date. So it does not know anything about the current affairs, current knowledge of current events. So that is solved by the adding tools, making it an agent. So the first one, we build a RAG to solve the problem of providing the internal answers from the internal data, from the company, organization, confidential data. There are a lot of questions. I mean, every time I talk about this, how about security? Why do we send out our company information to the model and all of that? We'll talk about it. It's not just you're going to throw everything and sending out to a model. As per the architecture, your complete RAG application is just another application of your organization that lives within the network of the organization. Just like you have a cloud account on Snowflake, just account you have AWS cloud account, your data is sitting on AWS S3 or Azure Blob in the network. Your model will also sit within the network beyond the firewall or a wrapper, and endpoint is exposed. So that endpoint will authenticate you before sending the request to the model within the network, and only the data that you have access to will only be provided to the model. Okay, all that security guardrails, everything will be in place. We will talk about it in detail when we get there into it. So retrieval augmented generation, we have been talking about this, is an AI framework that combines information retrieved with text generation to improve response accuracy. Okay. Why it matters? It has limitations in knowledge cutoff. RAG helps bridge this gap. Examples: chatbot retrieving up-to-date company policies before responding. And then it has a fixed knowledge base that we know based on only the training data, inability to access real-time information, all of that. So what are the use cases? as I said, customer support, research, legal, healthcare, any organization that wants to build a chatbot that can answer from its internal information, whatever information they provide. We talked about RAG components yesterday. Last week we built semantic search application, which has retriever, generator, embedding models, and vector database. So the missing element here is adding an LLM model to this. The generator is the LLM model that is part of the entire RAG. And we already used retriever and embedding models and vector database to build the semantic search application. So we are going to add the generator to it. So that will complete the RAG architecture here. So that's what we talked about. The first retriever is retrieving the data from vector database and embedding vector database using the embeddings that we provide. Augmenting is sending out all of these results from here, plus the user query coming from here. Both of them, you send it to the LLM model, and the model will respond. That is the text generation that is done by the model. So that becomes retrieval augmented generation. So over the evolution, the simple RAG was not enough for various complex use cases. So over the years, what evolved was a complex RAG, a hybrid RAG, where you combine this RAG architecture with your standard SQL, your SQL based retrieval filter, basically. So you add a SQL database results, SQL query, filter the results, and then you send it, you get the RAG architecture results, both combine and send it to the model. That's a hybrid search that you want to do, hybrid RAG that you call. Another one is a graph-based RAG. That is another architecture that is coming up, that can be used for the chatbots. So these are the different versions, or you can say the different flavors of RAG that is coming up that you can use for building the chatbots. Hybrid RAG and graph-based RAG, and you can read about it. We'll talk about it later sometime. Use cases, again, same thing we talked about: chatbots, healthcare, research, e-commerce, anywhere that you want to give internal information to the model to process and get some information out of it. So not much of theory. It's the same thing we have been talking about over last weeks, 2 weeks, and this is the third week we are talking about same components. Okay, so we'll get into the demo and we'll continue from where we left off when we created the semantic search application. Okay, so any questions before we get into the demo? Hey guys, no questions? Anyone? All good? Okay, all right. So let's get here. So we're talking about LangChain. As I mentioned yesterday, we'll talk about various frameworks through this training, right? So one of them is the most popular and the basic platform or the libraries that we have is the LangChain. So LangChain libraries or LangChain is used to stitch all of these components that we see here. Okay. All of these you can stitch using the LangChain library. Retriever, you can build a retriever to pass the query to embeddings, search the vector database, get the results, and then pass it to model. You can write functions, all of this, and stitch all of this workflow together to build the RAG application. So that's the most popular and adapted library called LangChain Academy, that you can say. LangChain also has other components, LangSmith, LangGraph, and LangGraph Studio. Earlier it has LangServe for deployment. Now LangServe is retired. What it have right now is the LangChain and LangGraph. LangGraph is for building agents, agentic AI, and orchestration. And then LangGraph Studio is for deployment, and LangSmith is for observability, monitoring, tracing, evaluation, and all of that you can do with LangSmith. So we will discuss the LangSmith during our observability sessions, and we'll touch upon the LangGraph. When we build agentic AI, we will pick some of the frameworks where we can build the applications using any of these frameworks, the agentic AI applications. Okay, so we'll start with LangChain OpenAI. Okay, I guess I have made sure how we run the. Oh, sorry. Just let me install this. So I'm using OpenAI API key again because I'm going to use the model and embeddings. So before going to embeddings and models, we talked about, I just want to see how do you talk to an LLM model through API. So we all know that we have been talking to the LLMs using our chatbots, basically applications. When you say Chat GPT or you say Anthropic here, these are all like, it's a chatbot basically, or it is an agentic application where inside it internally it is talking to a LLM model. Okay, or Chat GPT is talking to a GPT model, where again you can go and select here which model you want to use when you are chatting with the application. So you can select any of this model, it will switch, it goes and connects to that model and brings out the response. Okay, now here I'm directly talking to any of these models like OpenAI model without this application, directly through API. So we have shared the document, right, to create OpenAI API key, and using that key, you can set up the key here. Just put OpenAI API key and that key here, and you can get access that using this boilerplate code here, OpenAI API key. Even in production, in your organization also, these keys will be, or authentication will be stored in the secrets. Of course, you will get internal endpoint, so you don't need to actually send the API keys, but you get the internal base URL, internal version, internal model name that you use, that is installed to call that internal endpoint, and that endpoint will take care of connecting to the model. Okay. Now from LangChain OpenAI, import Chat OpenAI. This is the LLM model that instance I'm creating an object to talk to the model. So Chat OpenAI, here I am giving the model name. So you can give any model you want to talk to: temperature, max tones, timeout, and max retries. Okay. You can also send additional parameters here, but these are the basic parameters. Now I'm asking a question to the model llm.invoke, and then I'm sending my query. What is the capital of France? It's just like, typing out here, what is the capital of France? The same thing we are doing through our program. Okay, our code. Now, when I print this, you see there is only, the response is only 2 words, the capital. It cut off there. It didn't give me the complete answer. Do you see why it is not given to a complete answer?
Okay, these two.
Yeah.
Above, we have said that.
Correct. So we talked about this. How do we control the tokens that is coming out of model, right? So if I set max tokens to here, no matter what question you ask, you always get only 2 tokens out. The model will only send the first 2 tokens. That's it. It will not generate more tokens out of it. Okay. So that's how you control the tokens, max tokens configuration here when you create the model, these parameters. You can create, control temperature, you can control the model name, tree size, and all of that. Okay. Timeouts and everything. And then I will go and remove this and say my max tokens is 1000. Now I will rerun this. Now my LLM model can generate up to 1000 tokens. Now if I run this, see, now I get the complete answer. Okay. This is how you control the max tokens.
So
Now,
we will get the charge for the maximum token, right? OpenAI, if we are calling OpenAI, they will charge us.
No, it charges only on based how many tokens it's generating.
Tokens, yeah, generating.
It's now generating here 6 tokens, so you will be charged only for 6 tokens.
And previously 2 tokens.
2
tokens.
tokens,
The
yes.
cap, yeah, okay.
Yes. Yeah. And so you need not worry at the token level because, as I said, you can generate up to 1 million tokens for less than $1. 6 cents or something, 60 cents something. So it has become much cheaper now, the inference costs. So that's okay. But organizations still set this. So even if you just create a model, they're going to append that number or that configuration internally before they send it out to the model. Okay. So that configuration will be.
Yeah. So how they will send us the bill means actually how much dollar we need to pay or something like that.
You don't need to pay. So you're talking personal, right? This one is we gave you the document, right? How do you create an OpenAI API key? So when you create a key, there's on the account you have to give your credit card, and then you can what you call charge your account with say $10. They keep deducting from that. Okay. And then you can top up the account when it is done. So, but normally I have seen for the entire this training, I don't spend more than $10 for this. I've been telling this again. The only place where you spend more money is when you are using platforms like Bedrock, Vertex AI, Google, or Azure OpenAI Foundry to build some of the knowledge base or RAG or Agentic AI and run that. It create indexes. It processes a lot, and then it gives you a charge. So I've paid like $50 in a month training all the way up to $500 sometimes, because of some things I forget and some mistake. By mistake, I put a lot of data to process, create all of that and forget. So you can get into all of those with the platforms. But if you take out, because in our training, I will touch only the Bedrock. If you take that part out, so the only thing you will occur when you do the training, the complete additional expenses only for the OpenAI key, no less than $10. Okay. So what is the capital of France? How is weather today? So see here. Now this is hitting the second limitation. I am unable to provide real-time weather updates. Okay. Because we know the model, right? When you talk to the model will say it will answer only based on its knowledge. I think last week we also touched upon how do we know whether it is answering from its own knowledge or from our own content? How do we control that? In ChatGPT, if you go and ask, it will give you the answer. Even if you go ask here, the same question you ask any Anthropic client, if you ask the same question, to any client here, Sonnet or any model that you use within the Claude, Anthropic, right? See all of this, it is searching the web. You can see here, it does not know, but it has tools. It's an agent actually. So it has tools. So it can connect to the internet and get you the information. That's what it is doing to get all of these results. However, here, there is no such thing. You are only hitting directly the model. This chat GPT-4o model. So it can only answer from its own knowledge. It does not have any other resources here to answer your question. So that's why it's saying, I am unable to provide real-time weather updates because it has cut off knowledge date. Only knowledge after till that cutoff date only it can give you an answer. For the most current weather information, please check reliable weather website or application. So it is helpless. As a model, it can only answer whatever it has been trained on, what knowledge it has. Okay. Now, we will rephrase the question and ask the model, and just I will remove today. How is the weather in Dallas? I will say during December. See, now it can answer. In December, Dallas typically experiences mild to cool weather, average high temperatures, because this is generic. It knows historical data. So it is answering from historical information that it has been trained on. December, not this December, this year, right? So we are talking in general. So whatever the previous historical information it has been trained on, so it is answering from that, generalizing the results, generalizing the weather during December times. But the moment you say today, this year, this month, it is helpless. It cannot give you the correct information on that. So that's how the first limitation. The second limitation, that it does not have the current knowledge of the current state of affairs, where you need current events, where you need to enhance it, give it some tools, okay, to connect to the external world and bring that information for you. That's where the model evolves into an agent. Okay, one of the that is one of the resources that is needed to evolve into an agent. The model evolves into an agent once you keep adding these capabilities, these resources to the model. Okay, so two limitations we are talking about: internal company information and the current knowledge. So this is the current knowledge state of affairs. Okay, and the same thing we also know, it cannot answer the information that it does not have, it does not know. Now, I am building a messages, right? So we talked about there are three types of messages: system message, user message, and AI message. System message is generally the instructions to the model, just like what we set some configurations here. You can also give some instructions to the model itself. We say, hey, answer the question in just one word. Human means, system means it will take it as instructions. Human means it will take what is the actual question that you are asking the model. So it will answer this question, keeping in mind or limiting to these instructions. Okay, then when you invoke, you get back the response. That is what we call the AI message. So the response that it sends is of the type AI message. So these are the three different messages: system message, user message, and the AI message. So once I get this, see here, the AI message, the answer, the response is just one word, because we have given the instruction to just respond in a word. This we have been already doing even in the chat GPT. When you summarize, you say summarize in 1,000 characters, summarize in one paragraph, provide in 5 bullet points. Those kind of specific instructions we give, those are more like a system instructions. So in the organization, they can put a lot of instructions here, use formal tone, you know, discard any personal information. Of course, you can do partly in the guardrails. You can also set some instructions in the system message as well. Okay. Respond in bullet points, or do not generate any code, something like that. You can give instructions here in the system message, or you can give the role. You generally you write, right, that you are now a legal expert, or you are now a marketing expert. Those kind of roles also is the instructions that you give here. History you can give here. Whatever instructions you want to give to the model, you can give here. Okay, so this AI message generally has a lot of information. Okay, it gives the response in content. Then it will also give the tokens. Completion tokens is 1. Prompt tokens is 25. So you are sending 25 tokens to the model. The model is sending back only 1 token because you said just answer in just 1 word. As I said, you can also control here and send it to the model. What is your max tokens? You can also give here and then talk to the model and say, give the system instructions. Okay. This will take precedence over your system instructions. Total tokens, input tokens, output tokens, fingerprint, everything is here. The same thing you can also see when you go and look at your tracing and monitoring. When you add any of the tools like Langsmith, Langwatch, Langfuse, any of those tools to monitor, you can use that to see all of the tracing. It will also trace input, output, which model has been called, how many times it's called, what are the tokens, how much it's charged, how much time it has taken. So all of that we will look at when we talk about the observability. Okay. See here, this is what you are a helpful assistant that translates English to French. English to French, then translate the user sentence. This is your system instruction. Human, what is the capital of France? Now, what it has to do? When I ask this question, what do you expect the answer? It has given the answer here, right? It has given the
French.
Answer. Capital of France is Paris.
Yeah, Paris
The
in French.
In French?
So, yeah, so capital is...
it will give the
capital of
in,
France is Paris in French. The whole statement should be in French.
It gives the capital is Paris in French.
Yeah.
Okay. Any other answers? That's right. Close. Any other answers? I don't know French.
It will translate the question in French.
Right. So Deepak, it will not attempt to answer the question at all.
Yes.
Because you are saying your job as a model here, as an assistant, is just to translate. You are a translator. You are not trying to answer the question. Okay. So it will not attempt to answer this question at all. All it does is it takes this and then converts to French. That's all you are asking the assistant to do. So here it will, as it is, it will just translate your question into French. So you don't see any Paris here. So it's not attempting to answer the question. Rather, you just translate the question here. That's what you're giving the system instruction. So whatever questions you keep asking the model, it will only convert it to French, from English to French. It does not answer any of your questions now. Okay. So the message content, just it will give you this one question. Now you can change the functions. As I said, in the LangChain, you can create a chat prompt template. So I have a system message, I have a human message, I am getting the AI message as well. So I'm giving your helpful assistant. Now, instead of English to French, I'm making it parameterized. So I can pass parameters, just like any programming language functions takes parameters. You can parameterize it and generalize now. So your system message is now parameterized. It can translate from any input language to the output language. So you can now use any two languages to translate from one to other. Human question. So you can pass question to this template. So you're creating a chain, this prompt, chaining it with your model. So when you use this chain and invoke, it will take this prompt and then send the prompt to the model, right? So that's what we are talking in the architecture here. So the prompt to send it to the model, we do the chaining of this template, prompt template and model and user query and all of that. Now, when you invoke the chain, there is a prompt, and the prompt is expecting three variables: input language, output language, and question. So you send a JSON like input, like parameters. What is your input language? What is your output language? And what is your question? So my question is, I'm going to convert from French to English, and this is the sentence. So when I run this, it will automatically convert this French language, the sentence in French, to a English language. So you can switch whatever, whenever you ask, you can switch any languages and ask a question. So it will always give you that. So all you need to do, just take response here and change any of the languages. Okay. So I will put from English, I will put Arabic. Or just let's say French to Arabic. See, so this is your Arabic translation of this French sentence. So basically, this is how you communicate with your LLM model using the applications, using the API that you use. And then these are all how we control the prompts, user prompt, system prompt, AI message prompt. You build the conversation using all of this. And tokens, control the max tokens and other configuration here. And this is how the model works. Now you see the limitation, what it can answer, what it cannot answer, what information it has, and what information it does not have. Okay. And then I will say here,
So one question, what if we are not passing the desired input that we have told that AI, like it's going to be French, but we passed, let's say, Arabic. So is it still going to give some error, or it will just go and translate it?
no, it might just error out. You're saying here if you just send
Yeah,
English,
that's
then
same thing, and we pass input, whatever we got the output as Arabic. Yeah, that's also fine.
see.
Okay.
So it
Okay,
is
so
looking for some text in French.
okay,
Okay,
so
it handles that.
this one is doing that validation and all. Okay.
Yeah. Okay. And now if I say some question I'm asking to it. which it does not have. Sorry, but I don't have access to personal data about individuals unless it has been shared with me in the course of our conversation, right? So it is not, this is the first limitation we talked about. The second limitation we have seen about the current events. This is the first limitation that we have seen. It says I don't have access to personal data or any your confidential data unless it has been shared with me in the course of our conversation. I'm designed to respect user privacy, confidentiality, or projects. I might be able to help with general advice about information. So the same question, if you want it to respond, we have to build the complete RAG architecture. Yes, Pawan.
Sir, I have a quick question. So far, like we are sending the question through program, through code, and getting the response through code. In general, in a practical world, how do we integrate this with the UI? Any tools, widely used tools are there? Like how that happens? Can you give us little
Yeah.
insight?
Once you build everything like an application, right? So as I said, you can use Streamlit app, you can use Fast API, any of these UI UX design applications languages to build a function, to build a UI, and then you invoke these functions from there. Okay, you kind of get it all of this into a endpoint, okay, or an entry function, a main function, and then you deploy it on an endpoint. You can use it an API, or you can just deploy it as a application, and then invoke that function from your UI. So all of this, just like any of your Python code, just say you have a Python application to get to process some files, or any to go to database and get you some results. So what would you do? You just go there and you will host this application, and then you run that application from UI. You give some inputs, or select a page, select some keys, or search for a key. It goes and invokes that function, and that function will connect to database and get results. Same thing here. You invoke that function. Now this function will, in addition to having all of this connection to vector database or your normal database, it'll also connect to the model to get you the proper answer in the chatbot.
Just like hosting any web service.
Yes, absolutely. So you can host it, the entire thing, on a Azure function. You can host it on AWS Lambda as a Lambda function, or you can host the entire application with the Docker container and then host it. And the Docker containers, you can scale it up with Kubernetes pods. So all of this architecture still applies to these AI applications as well.
Okay.
Okay. Awesome.
Okay, yeah. Thanks.
Thank you. Any other questions? So now we are very clear about how we initiate a conversation with a LLM model through APIs, right? Not through chatbots. So we are trying to build one chatbot with that. So we'll move on to building a chatbot. So for the semantic search application last week, we talked about getting the semantic search results. We uploaded a resume and asked some questions, right? And then it gave you some chunks of output data. I don't know if we remember, if we have that. Let me. Okay. So This is how we build the semantic search application. And then we had these questions. What are the projects executed? What are the certifications? So it gave these results, just it threw us kind of some chunks of data at us, but we can't make much sense of this, not in a human readable format. So we wanted to provide or augment this, add our LLM model to this and feed this data, whatever we are getting retrieved data to the model, and then try to get a for properly formatted answer for this to complete the chatbot. Now we will do all of the same thing here, whatever we are doing, and then add up a model to it where it can take this information and this question together and then give you the result. Right. So come here. I'm using FastDB as our. Oh, it's not Pinecone we are doing. Okay. So instead of Pinecone, here we used Pinecone as our vector database, right? Now I'm using FastDB. So remember we did FastDB, we did Chroma, now and Pinecone. We did 3, right? So here I am doing FastDB as the vector database, GPT-4 as my model, and embedding models. Also, I'm using OpenAI embedding model here as well. Okay. Now let me install all of these libraries first, and then all of this boilerplate code we looked at last time, document loaders, PyPDF, chat, text, character text splitter to split the characters. Then we OpenAI embeddings, chat OpenAI, vector stores, files, chat prompt template, runnable pass-through, all of this boilerplate code to process the input documents, whatever PDF documents, to split it into chunks and install and send it to the embeddings to generate embeddings, right? So all of that, all the needed libraries here we are loading up, reading the OpenAI API key from here, just like we did earlier. We are using a chunk size of 1,000 characters, overlap of 200 characters. So there are several chunking strategies we talked about, and then there is a this one document. I'll send it out to you. You can go through. I don't know if I've already shared with you about 20 chunking strategies that you can look at. Use what are the different strategies that you can use while choosing a chunking strategy. Okay, so what happened? This is done, not done yet. Take some time. Okay, restart session. Yes, just restarted session. We will run this. So what are we doing here? I have to put it in different widgets. What's that? So this is the file path, chunk size. We are loading up the file from the documents from PDF. Doing character. Can you please paste the link in this chat to practice collab notebook? I believe. Which link for this notebook? We are adding all of these notebooks into a shared drive. All the notebooks you will have access on the Google Drive. It should be there in the in the group. I will again reshare that name of the drive where you can find all the notebooks that we are discussing. Okay. Chunk size, chunk overlap. So we are splitting the chunks, and then I'm using OpenAI embeddings. So it will use default, whatever is the OpenAI -002 to generate embeddings. And from the FastDB, we are adding these embeddings and chunks to the FastDB. There is a retriever I'm getting 4 results when I am searching. So I'm setting k-args as 4. So to get similarity search, 4 results when I search. Model I'm using GPT-4o mini. So that is the LLM model. So there are two models that we are talking about here. One is embedding model and one is the LLM model. Okay, embedding model we are doing default. This we are doing 4o mini. And we are building the template again. So whatever we talked about, answer the question based on the following context from the PDF document. We are passing the context. So the context is basically the results that we retrieve from the vector database that we will pass in the context. Okay, this will serve as your system prompt. And then you can pass question here. So everything in one prompt. Instructions also I'm passing here, just like system prompt. Answer based only on the provided context. So I don't want it to answer from its own knowledge. If you don't have enough information, say so. Be specific and accurate. Keep your answer concise. So these are the instructions, system instructions that I'm giving, system prompt I'm giving to the model, that answer based only on the provided context. If you don't know, if it is not there, don't answer. If you don't have enough information, say so. So don't hallucinate, basically. Don't try to invent some answers on your own. Rest of all is just like, boilerplate code. You don't need to worry too much. All of this is again generated by AI only, by one of the models, Gemini models I used to generate this code. That's why you see a lot of emojis in this content. Okay, so you don't need to worry about this too much about what is the syntax, what is the functions and all. You should just understand high level flow, what is happening. So we're building a RAG chain just like we built here in the other. We are using the context is the retriever from the format docs for the question. So retriever will get the results from the vector database, passing it to the prompt, and then passing it the prompt to the LLM and to the output parser. And then we have questions, functions, ask question. You send the question to it, and then it has to, the question has to be ragchain.invoke. That is this one, ragchain.invoke. You send the question to it, and you get the answer. So I'm just firing up a set of questions in a list for it to answer all the questions here. Ask a custom question. You can ask any question like in general. So these are what we call convenience. For your convenience, I'm just writing different functions to test the model. Okay. Search document, get relevant documents. This is the retriever that we are saying default. We have given 3. It will go and get the retriever docs from there and then do some processing, page content and all of that. So that is it. And then we have our questions here. Okay. So if I run this question, run all of this. Okay. So we got an error. Processing file is not a valid file or URL. If we don't have that file here, we'll go and upload the file. It says file not found. Go and upload the resume file here. only for this session, and then we will rerun this program. Okay. So key setup initiated, processing the file, loaded 9 pages from the PDF. It has split into 43 text chunks. It has created embeddings, 5 vector store created, and track system is ready. Question answering system is ready, testing with sample questions. And then these are the questions. What are the main technical skills mentioned in this resume? So you see a very formatted, neatly formatted answer. Okay. The main technical skills mentioned in the resume include programming languages, data tools and technologies, AI, machine learning, data integration, security, data transformation, technical program leadership, versus what we have seen here for the technical skills, projects, certifications, where did okay, something like that. So you get, even for the skills, you get something like this, this thing. What companies has this person worked for? Are you guys able to hear me? I think I have some network glitch.
We can hear you.
Okay. So what companies has this person worked for? It was able to extract the company names from the resume. Maybe not all, some of them. So you have to see what is the format and what you need to understand as a company that has worked for. Educational background, I asked, it says the provided context does not include any information about the educational background. So in the resume, I have not added anything about your educational background. So it's not able to find that information, but it has clearly spelled out that whatever context I have does not have information about this. Certifications or achievements, then it clearly mentioned out in bullet points, what are the achievements and certifications. Another question, what is the current role and company? It says does not specify current role or company context, so which means it is not able to read that part. So we have to also, this is where the training comes in for the model, how to understand. Let's say this is a resume screening application, for example, the HR users, right? And then they are trying to look at looking at answers for all of these questions. They don't want to read all 9 pages or 10 pages for each candidate, right? They're trying to answer this question. Now, if you get all of these answers to evaluate at a high screening level, but say it does not have a current role in company, which means the model is not able to properly parse that, or the vector database is not properly giving you the results, right? So this is where your tuning comes in, tuning the model. You have to now explicitly give instructions what you mean by the current role or company. Maybe you can say, hey, where you find till date, that is the person's current company. The role is generally followed by the company, the name of the company, or you give examples from 2 or 3 different resumes or 10 different resumes, how people put their company and role, in different formats. They mention next to the company, or they mention in the next line or whatever. So you give 5 or 10 examples to the model, short examples, to understand, hey, this is how you read and understand about a role of the person in the company. So that's how you go and tune that. Or maybe you want to change the strategy, basically your chunking strategy. You want to take project by project, or your tenure at each company. So you can split your documents based on that. and then you can say at the top you have your company name instead of, sometimes if you 1,000 characters, it might split suddenly in the middle of company name or in the middle of the role or middle of whatever it is. So it might lose context. It cannot join those two to come up with a proper answer. So these are the things where you have to step in, where you need to look at what is going wrong, where it is going wrong. Are we getting the relevant results? Are we getting from vector database itself? Is our chunking strategy right? Or do I have to tune the model further, to screen the resumes kind of a thing? Then summarize the projects in 10 lines, format, response, and bullet points. It was able to, this also you have to see, is it correctly picking up all the projects? Take a couple of resumes. When you do evaluation, you take 10 resumes and you write your test cases, ground truth, and then you ask these questions to the RAG application. You get a response. Pass this response to the manually written expected output as a ground truth. Compare the ground truth with this answer. How do you compare? You go and create another.
Arun, your voice is breaking in between, Arun. I'm not sure if it's only for me or it's for all.
It's for everyone.
Oh, is it?
Yeah.
Network.
Arun, your voice is breaking in between.
It's choppy, on and off.
Network is all fine. Are you able to still same thing or better? Yeah, I think the internet connection is a little bit choppy. I don't know what is happening. Is it okay now?
I can hear you well now, but it's been, on and off.
Okay, you can hear now, right?
Yeah.
I know there's some network issues happening around. Okay. So, till which point are you? What's the last thing that you heard? Hello?
The chunking strategies to,
Okay.
fix
Yeah. So basically, that's how you have to look at various things. Is my chunking strategy right, or do I have to change how I am doing the chunking? Are my vector database results fine? Are we missing something? Is my model properly able to understand or not able to? Do I have to give some more examples of how it should understand this question, get this information from the results? So these are the things that you can do for tuning purpose. And you can also evaluate this entire RAG application with the evaluation techniques. So for example, I'm getting these projects, summarize the project in 10 lines and format the response in bullet points. So it's getting all of these projects. Okay. Now, is this the complete list of projects, or all the projects listed, all the project names are correct, and is the information mentioned that it is saying that this is a project is correct or not? So all of this you do in the evaluation using one of the evaluation tools, as I talked about, right? Langsmith or Langwatch, any of these. And then you do, right, you take 5 or 10 resumes, take the projects out and say, this is the ground truth. This is how the project should appear for this question in the response. Take those and write test cases. Then pass the same question to this model, to this application, RAG application, get the response. Now you have to compare these two. How do you compare these two? You pass the response coming from this application, RAG chatbot, screening application, to your ground truth, what you have manually written, it should look like. Take these two and then pass it to another model. So that will be like LLM as a judge. So that model will take both these answers and compare whether these two are correct or not. Not exactly the text, but are they representing the same response, completeness, accuracy, truthfulness, all of that. It will see if they have the same information, complete information. Then it can say true pass, or it can give a score. These match 90%, or these match completely true or false. So all of that you can do while evaluation, and then it's a feedback loop. If it's not, the result is not good, the results are saying too many test case fail, they are not getting the exact match, or the accuracy or is like less than 80% or 90%, whatever benchmark you have, then you come back and do all of these things again. Evaluate the chunking strategy, evaluate the vector database results, evaluate whether you're getting too many results, too less results, evaluate how the model is responding. You want to change the model, or you want to give more examples to the model. So all of these things that you look at to fix your model's performance. That's what you, even in the interviews, they ask you, how do you make sure your model is performing well? So this is the entire process, end-to-end process you set up to look at the results, to look at the testing results, and then what are the levers that you have to tune to perform the, improve the accuracy. Again, issuer of the information security policy, it says does not specify the issuer of the information security policy. So these are the question and answers. Setup complete. So you can ask a custom question here. You run this. This is your chatbot. You have your resume. Then you ask any question. Let's say ask, give me the email address, phone number, and LinkedIn URL for this person. Okay, see here. Now you got the email address, you got the phone number, and then you got LinkedIn URL. Okay. So this is the perfect screening application chatbot that you have. You can ask any questions about the resume and you can get the response back. Okay. So now here is where the other aspect we are talking about. We talked about how observability fits in, how evaluation fits in, and then this is where our guardrails fit in, the security. If same application, if somebody is using it internally, they should not be able to see the PII data, either phone number or email. These are confidential. You don't want to share with everybody. So you run the guardrails before sending the response out. If it is actually giving out your information, phone number, email, if you want to block it, if you want to mask it, you can do that also as part of the application. You build the guardrails, you scan both input and output, and you do this response. Okay, so that's how we have built a chatbot for resume screening application. And same thing, all you need to do is I put one resume in a folder. Maybe they have a folder where they keep dumping all the resumes, and then you just need to pick up and process all of that. Nuts and bolts you have to build. This is the core engine. Now you have to build all those wrappers, nuts and bolts, the security, authentication, a nice little UI. Again, the same box will appear in that UI as well. So they can go and type away all their questions and get the response. Or you can give some screening score based on these questions that you have evaluated, whatever requirements that the HR goes through, and then come up with answers. That's your little application chatbot, that resume screening application that you have built. Yes, Kirish. I'm not able to hear you. I guess you have some issue with the microphone. Last time also you are saying you're not able to talk or something. You're not able to hear you. Can you ping on chat if you have any question? Just to check. Okay, I can see here. Hey, what is happening?
Hey, Harun, can I go ahead with the question?
Yeah, sure.
Okay, sorry, maybe I don't know if you have answered. I joined a bit late, so apologies. But I want to understand if after chunking the responses are not great, is there a way that I can go and re-chunk the inputs, or what are the different strategies? You mentioned like we have to put a question and answer and basically train the LLM in the right way. But before we go to that path, are there any tools during the chunking process itself to take care of better chunking?
Okay. There are no standard tools. It's all like strategies, more like application that you do. Just give me 1 second. Let me see. I would just show you right here. Okay, 1 second. So am I still sharing my screen?
Yes, we could see the Google browser. The browser.
Okay. I don't know what is happening with my system right now. I had this. Okay, I have this URL. So this is the blog that I generally refer and give it to participants, right, to go through to give you an example of what chunking strategies does. So there are about 21 strategies listed here. Most of it we talked about. Naive chunking, just split by new line. This is one strategy. So every line becomes a chunk. This is one strategy. Fixed size, that's what we are doing, 1,000 characters, 500 characters, whatever. It kind of breaks here. See, we looked at the numbers yesterday, and this goes into one chunk. And from, I think, hold on to system, it goes to another chunk. So it breaks abruptly wherever the number of characters it looks at. Sliding window, same thing as this, but it repeats the previous, the system, right? So I'm just overlap. So I'm overlapping 10 characters. So yeah, okay, the system, then the next chunk starts with here, from here, the system again, yesterday, and it repeats the last few so that you see that connection between the two chunks. Sentence based, again, it's not new line, but it's a full stop. Wherever the sentence ends, it becomes a new chunk. Okay, chunking by the sentences. Then paragraphs. Each paragraph becomes a chunk. Page based. Each page can be a chunk. Structured. If you are getting a structured data, JSON structured file that you are getting in the file when you are parsing, you can say each record. You can do each based on the tags. Each record can be one chunk. That's one strategy. Document based. Very popular and helpful. you have a reports, right? Most of the times, if you have reports, it has sections. You can take each section into one chunk, which makes the retrieval easier. Let's say you have skills, resume also, right? So generally each section, like projects are in one, skills are in one, certifications are in one. You can do a chunking based on the sections that you have. But for each chunking strategy, you should be aware of what the input sources look like. Of course, any input source you would look at and build a system for that. Even if it is CSV, JSON, XML, you need to know the data contract, right? How your input is going to look like, if not 100%, at least 90% of it. So this is one document based. Keyword based, you can do. Entity based, you can do chunk 1, Oppenheimer, chunk 2, Barbie related, chunk 3. So based on named entity recognition model, you can do implement those. Each one, you can use other tools to implement and come up with a chunking chunks for which will fit your use case. Token based chunking, maybe sentence chunking, splitting sentences. Instead of that, you can do token based. Topic based, you can do, which will result in these chunks like clusters based on which topic they are all divide. Table aware, you can do each row as a chunk or based on columns as a chunk. That is another chunking you can do. Content aware, paragraphs, tables, lists that you have in the document. So these are some methods, but implementation, yes, you can figure out, write code, use tools, whatever. See, the end goal is to split a document. That's it. Strategy will tell you how you want to break it down into smaller parts. That's all the strategy chunking is, contextual chunking. So these are like several, embedding chunking, agentic chunking. You can leave it for the agents to do the chunking based on the structure of the document. So all of that can be implemented. So you have a kind of a report. Typical reports have this images, tables, then some text document, then some more images and all of that. So you can get each of this into a different chunk, modality aware, different types of content, text, images, tables. This is another chunk, but how you do it is not yet. It's up to you to figure out how you want to. There will be tools to, when you read a PDF, you can do those kind of chunking, or you can leave the agent figure out how you want to do this chunking for this. Hybrid chunking, you can use one or more of these methods you can combine. Okay. So this is one kind of document that you can refer to go through different chunking strategies.
Thank you.
Okay.
This is useful. Yeah. Thanks.
Yeah. So let me give you this right here in the. Is that? I don't know if I'm.
Is there a useful URL list you have somewhere on the Google Drive?
It's more like, so in the documents store, I can put it there in the Google Drive that I'm adding all the artifacts. I have added one to do the OpenAI configuration. I will add this document as well there. And then as we go forward, any projects, use cases, assignments, useful documents, I will keep adding there as a library you can refer to. Okay.
One quick question on the instructions, Harold.
Sure.
I'm trying to build a project on ChatGPT. I know, is there a template for the instructions? I saw some instructions on your code there. Do you have a standard template you use for projects? A template for the instructions?
Template for instructions. I didn't get you completely.
So for example, you said, if the data is only referenceable, respond with that. Give me citations. Basically the guardrails which you're putting in the instructions. Is there a standard template do you have?
No, there will be no standard template. It depends
Okay.
on case, whatever you are dealing with. Every use case comes with your own instructions. But when you get to guardrails, there are some libraries that we discuss about. We will discuss about. One is your Llama Guard from Meta. There is another Proctor, Proctor.ai. They have inbuilt guardrails. You can directly use that platform and get those off the shelf. You can use those list of all guardrails like PI information, tone of the language, hate speech, detecting the code if you're sending the code, or any what you call competitor names analysis, forbidden URLs if you're sending any URL. So all of that, for each you have a off the shelf guardrail that is built. It's just like Python code built inside with regex and all of that, some intelligence. So you can take that directly and then use it as a list of scanners that you pass through your input and output. But again, we can try to build one if you have some idea how you want to, if you have, how you visualize it, we can definitely get on. We are building a lot of projects, building the GitHub now with all of these. So right now what we have built in our class is a resume screening application or a chatbot. We have the core engine. We can make it a full-fledged project and host it on GitHub. We can collaborate. Pavan is here. He is leading all of these projects to be built and hosted on the GitHub. All we need is put in some UI, UX, and some guardrails or some additional, the bells and whistles to make it a complete application where somebody can, it just gives you more hands-on practice, confidence, building these, using this, and then you can say collaborate. We have this library, or we have this GitHub projects where we are all collaborating and building the applications or use cases. Okay, great. So we will after the holidays or during the holidays, I will create a separate group. Pawan will lead that for building. I will, of course, I will be mentoring and helping and giving you that. Basically, whoever is interested to contribute to build projects and put on the GitHub library, we can bring our use cases, we can do brainstorming, and then we can build hands-on projects, and some of might evolve into products as well, right? So that's how we wanted to take this forward. But I just wanted you to have a very high level understanding of all of these. We have not yet gotten into the Agentic AI yet, but at least the components are clear. So we will slowly start, building those projects. Okay, so to let me know who wants to, has time, interest, bandwidth to explore and contribute, we will create because I just don't want to create a group and add everybody again there, and people are not contributing or not interested. So that defeats the purpose. It will become the same group like we have this. Sure. Once I create the group, I'll let you know. We'll add it there. Okay. All right, guys. Any other questions before we wrap up? I will get this notebooks and recordings to you soon. Apologies. I don't know why I'm having some network issues today.
Can you hear me or no?
Yes, Girish, finally. Awesome.
Okay.
Bring it on.
Yeah. So I think the resume that we created, right?
Uh-huh.
That one was I don't know if I can call it as a screening of resume, right? Because we only explained what is in the resume. So we broke up the resume into certain sections, right?
Correct.
If I have
Yes.
to add components like automatic scheduling the interview with the interview panel, or getting the inputs from the interview panel, and then collating all of that documents, and then finally sending all of that to the decision maker or the hiring manager. that will require other agents or other strategies as such, right? So is it going to be more of a multi-agent kind of a thing, or within the
Absolutely. So now you're talking multi-layered, right? So what I said was I built to answer questions from a resume once you feed it, screening application. Even in its raw form, it's not a RAG application, because as I said, you need to have some UI, you need to have some standard Q&A, and you need to have what you are looking for. Probably you need to have a scoring methodology based on if he has these skills, you put it on, give these much numbers on it and get a final score. If the score is more than 70 or 80, you say screening passed or screening failed. And each you feed in a job description for it to compare the key skills from there or experience from there with the resume. All of these things have to be built. That's why I said that's when it will evolve into a product. Right now it's a project. The project has limited scope. Now we need to add all of these bells and whistles. You can envision where you want to take it. So when you build all of this at a raw level, you're talking about one resume. I'm talking about you get 100 or 500 resumes. You feed in the job description. You should be able to go through, read all 500 resumes, go through the requirements, compare these two, and give you this resumes who have passed the screening. What you need to build, you have to define what is pass. It might be scoring, it might be qualitative or quantitative. You have to build that. How do you combine both the requirements from the job description to the resumes? That you have to build an agent, not just the RAG. You have to have an agent which is processing the job descriptions as well as calling the RAG to get the results from the RAG, comparing these two and then judging based on the score. There's a lot of brainstorming, a lot of requirements come out, and that will become your project. Now, add to it modules, right? As you said, can I pass the screening to round 2? Can I figure out, integrate it with the calendar to schedule an interview, figure out who's available on the panel, figure out their availabilities, match it with the availability of the candidate, send out a link. All of this is, as you said, multi-agentic AI workflow automation that you do it, right? So that becomes your product, end to end. You keep adding all the requirements, you keep adding all the modules to it. So that's a typical product you are building. It's not just a project, right? You can call it anything, but yes, the scope gets bigger and bigger, and the tools become more and more, the skills become more and more. It take more time, bandwidth to build all of that. Yes, if you want to pick that up, run with it, definitely. Yes, go do brainstorming, come up with requirements, all modules, what integrations you need, what skills you need, how do I build a multi-agentic AI with that, what platform do I choose, right? So all of that has to be there. You cannot build everything in just Google Colab, correct? Am I making sense?
Yes. Yeah.
Okay. Right. So, I mean, you have to start somewhere. So this is the starting point. Let's collaborate, build a group, build your assigned projects, and then see which one triggers something, that you want to take it to the next level like this. You triggered something when I said all the way we are doing the same thing, but we were calling it something else. We were calling just RAG application. But the moment I said it is a resume screening application, the functionality is still the same, but context is different. Now I'm labeling it, packaging it as some product functionality. I said resume screening. The moment I said resume screening, then you came up with, hey, if it is a resume screening, it needs to have all these things. Now that's defining a product roadmap. So if something like that triggers and you see potential, even if there is no potential, even if you're not going to sell it, but it gives you a strong confidence level that you have built a product, a resume screening product with all of these modules, integration, and multi-agentic AI. So this is where it's just a starting point. Yes, you can definitely explore and take it to the next level. Right? Okay. Awesome, guys. Any other questions before we wrap up? We're good? Okay. Yeah. So tomorrow we'll meet. It will be a shorter session. As I said, it will be a 1 hour session tomorrow. We will do more the same thing, building RAG applications with different, maybe we'll explore UI based tomorrow. How do you build a RAG application, the same application using an UI line flow? And you go for a short break, you practice all of this, and then we can still be connected, communicating on the group about what we are doing. And then after the break, we'll continue. All right. Thank you so much. Appreciate it. Appreciate your interest joining. Take care. Have a good rest of the day. Take care. Bye.
Thank you.